So like I was saying, we've got the sum, this means sum, and what we're doing here is a sum of each number minus the mean, which is cubed. So that's what we're doing here. So looking at the sum minus each number, so we're looking at the sum, the sum of each number minus the mean, and then all that gets cubed. This part here is cubed. We find the sum of all those values, and then we divide that by n minus 1 times by this, which is lowercase sigma, which means standard deviation. So we're going to look at how we can calculate a few of those things using Excel. Okay, so let's go to Excel. So here is my range of numbers. So we may be able to plot this as a graph. Let's just plot it as a graph to see what it looks like. Okay, let's see what happens here if we say insert a chart, we'll make it a 2D column. Okay, if we look at that, we can see it's not very well. We're just seeing our values there. There might be some sort of skew to that, but it's not a very good graph anyway. Anyhow, like I said, we're gonna calculate skewness. So what we do to find the mean, what we're gonna do, I'm just gonna write the mean is here, and I'm gonna say equals average, and I'm just gonna say equals average. So that's what I'm selecting. And now it's telling me the numbers, and I'm just gonna select these numbers all the way down, and I'm going to close that off. And that's what we've got as our numbers. So our average for this set of numbers is 21.18. And then I'm going to write SD for standard deviation. And I'm going to write equals stand. So we're going to do standard deviation, SD, of the sample, because we're not doing the whole population, we're just doing the sample. So if I double click that, there it is. And then I'm going to select the numbers again. And I'm going to close that. And we're going to say, so our standard deviation is 19.84. So our numbers, so our mean is 21, and our standard deviation is 19.84. So that tells us that, let's say this was hours taken to do something, that the average number of hours is 21, and it can vary. Each standard deviation is 19 hours. Okay, from that 21. All right, so now what we want to do, we want to be able to look at skew. So what we need all of, according to the formula, we need to do the value minus the mean. So what we're going to do is, just to make life easier for ourselves, we're going to say that this column equals this minus, and I'm just going to write this as 21.14. 21.14. So I'm just going to just make life easier for ourselves. That's what we're going to do there. So this minus that gives us that value there. So I'm going to keep going. Yep, that looks like it's just fine. And keep going right down. Alright, so that's what we've ended up with there. So that is all of these things. X minus X bar. From there, what we're going to do is we're going to cube it. So I'm going to take all these values, equals this, and I'm going to raise that to the power of 3. And I'm going to say we're going to do this. Hopefully this works. And we've ended up with that. So now what we're going to do is we're going to add all that together. So we're going to say equals the sum of all of this. And we're going to close that. And let's see, what have we got? We've got that number there, 29,209,000. So then from there, we've now got the top line sorted. After that, what we need to do is we need to look at dividing it by this here. So what we're going to do is we're going to say n minus 1, which is, we look at our values, we've got 36 different values. So n minus 1 gives us 35, so I'm going to put that in there. 35, that's how many values we've got. And then we're going to go across to here, and I'm going to say we've got our sigma squared, or our standard deviation squared, cubed. So I'm going to say equals this value to the power 3. So that's what we've ended up with there. So now what we're going to do is we're going to say our last thing, so we're going to say skewness. I'm going to say equals our total, which was this, that's our top line, divided by, open a bracket, we're going to say 35 times standard deviation cubed. We're going to say equals. So our data is skewed by 1.08. It is positive, so our data is positively skewed for this set of values. So if we were to turn that into a dot plot or a histogram, we'd see those being skewed. So that's how we calculate skewness. So to go through that again, we put our numbers into Excel, and just to check, just going to do something in a few minutes. Put our numbers into Excel. Mean, we've got a formula. Average, standard deviation S, we've got a formula as well. We put that in. It tells us both of those values. This is our value, so 51 minus the standard deviation of 21. We end up with 29. 62 minus 21, we end up with 40. 5 minus 21, we end up with 16, and so on. This line here is that value, is this value here cubed, and then this value is the sum of those values cubed. And then once we've got that, this is our n minus 1, so 36 minus 1, so we've got 36 numbers in the sample. That's our standard deviation cubed, and then we work out our skewness with our skewness formula, where we put the top line over the bottom line, which is what we've got here. So that's our top line divided by our bottom line, and that's what we do to calculate skewness. So we can say that is skewed by 1.08. And I think we'll leave it there. That should be it.